So this question were there, I think, in June 2025. Indirect least square is applied to estimate the coefficient of the which type of equation? Structural equation, and you can say other over identified equation, then reduced form of equation, then under identified equation. I think someone is cooking or something like that. Ajay is cooking. Okay. So you know all these equations, Sangeeta? What is structural equation? What is over identified equation? What is reduced form equation? What is under identified equation?
No, sir.
Okay. Madhusudha?
No, sir.
Okay, so it is coming from simultaneous equation model. It is good that because we have not covered the theoretical lecture for those sections. So in a sense, we will cover that, okay, today. So basically this question is covering estimation method for simultaneous equation system, specifically indirect least square for structural equation. So what is the answer? What is the answer?
Options 1, which is structural equation.
Okay, option 1 is structural equation. That is good. Okay, so ILS is used to estimate structural equation coefficient when exactly identified by the first estimating the reduced form, then deriving the structural parameters indirectly. Okay, so you can remember that ILS is used to estimate the structural equation coefficients when exactly identified. Okay, so now we'll go for detailed explanation. So what is indirect least square? So indirect least square is an estimation method for simultaneous equation models used to obtain the estimates of the structural parameter when the equation is exactly identified. Now we have to know what we mean by exactly identified. First, let's focus on the term indirect refers to the fact that we estimate the structural equation coefficient indirectly. So what you will be doing? You will first estimate the reduced form of equation using OLS, then derive the structural parameter from the reduced form parameter. Now there are so many things, so now we will start one by one. Well, first we have to understand what is simultaneous equation system. So what is structural equation? It is also called behavioral or institutional. Suppose for example, these equations represent the true economic relationship we want to understand. Like example, simple demand supply model. So you know that QD is equal to alpha naught plus alpha 1 P plus alpha 2 Y. This is a demand equation, and QS, which is equal to beta naught plus beta 1 P plus beta 2 W plus U2, it is a supply equation. So here what you should know, which is endogenous variable and which is exogenous variable. So what is endogenous variable, Madhusudha?
Sir, endogenous variable means independent variable.
Independent variable.
Yes.
1 second. One second, just 1 second. Okay.
Yes, sir.
Just I'll resume again. Just give me a second. Okay, so we'll start. What is the endogenous variable? The variables basically which is determined inside the system. Okay, like P, price. Now Madhusudha told the endogenous variable means which is.
Sir, actually it's Act like a independent variable.
No, act like means what? We are discussing simultaneous equation, na? Because you just see QD is equal to, you can see price is here also, and income is here. In supply also, like P is here also, right? W is here also. So now price is endogenous, and income and weather, so it is exogenous. Why? Because price directly it affects, actually we can say, the demand and supply. In this way we can understand, or if you know anything else you want to say, because it is saying quantity demanded and supplied, so they are also endogenous. Price is also endogenous. So both these three are determined inside the system. So the best book is, like if you go to the Gujarati or Basic Econometrics by Kursianis. Okay. So that there you can read more about this. Okay.
Yes,
Madhusen?
sir. Yes, sir.
So shall we proceed? Now, what is the problem over here? So basically this alpha and beta, they are called structural parameters. So this, they cannot, the problem is it cannot estimate this directly with OLS due to simultaneity bias. Why? The P is correlated with the error terms. Why P will be correlated with the error terms? U1, because you can see there might be many other variables which is affecting both quantity demanded as well as quantity supplied. Okay, both these equations, isn't it? Simultaneously or simultaneously. Are you getting? So, in what we can do is, if you will estimate it directly OLS through OLS, then there will be simultaneity bias because P will be correlated with the error term. Now what you have to do? You have to express each endogenous variable as a function of exogenous variable. Okay, like Q and P. You getting? So how we can go from the equation to structural equation to the reduced form equation? So that will take little time. So we can understand that also, not a problem. I'll send you some note, and some other day we'll discuss in detail. But let us see the what is the procedure. So this can be estimated consistently with OLS with no indigeneity problem. Okay. So what is the ILS procedure over here? So first you have to estimate the reduced form equation. Then you will use OLS to estimate the reduced form equations. Then you can estimate consistently the pi parameters which is there in the reduced form equation. Then derive the structural parameter, and then use mathematical relationship between reduced form and structural parameter. Then you calculate the standard error. Now let us see how it is done. So you just see how structural and reduced form parameters are related. Suppose we know the equilibrium condition is QD is equal to QS. Now what you have to do is, you have to simply equate quantity demanded equation to the supply equations, right? So if you will do that, so you can say P is here, you can bring P to this side, then if you will take the P common, so it will be alpha 1 minus beta 1 times P. Just you will rearrange, then alpha naught you will bring out to this side, alpha 2 also right hand side. So it will be B naught or beta naught minus alpha naught plus beta 2W minus alpha 2Y. So this is fine. This how you got this step from here to here. Madhusinda?
Yes, sir.
So Sangeeta, is it fine?
Yes, sir.
Now when we will solve for this, so solution is like we usually if you solve, you just divide across, right? So because these are constant, So it is actually directly it is will be dividing alpha 1 minus beta 1 over here. Then similarly with all other terms we are deriving. So then ultimately what we are saying is we express in terms of different parameters. So directly we are actually you can say if you will divide pi 2 0, that is this beta 0 minus alpha 0, then pi 2 1 is this coefficient, pi 2 2 is the third coefficient. So directly now we can say from the estimated pi at this value we can recover the structural parameter alpha and beta if the equation is exactly identified. Now what you should know from the examination point of view, so now you should not worry about how you can convert a structural equation to reduced form equation. Sometimes because you are doing it first time or if you are doing it after a long time, it will take little time, and when you will discuss in detail, so it will take at least 2 to 4 classes to understand it. So now from the exam perspective, you should know what is the identification condition. So ILS only works for exactly identified equation. Now you should know what are the 3 conditions: under identified, exactly identified, and over identified. So condition is k is less than m. Okay, k, what do you mean by k? K is the number of predetermined variable excluded from the equation, and m is the number of endogenous variable included minus 1. Then now question is why it is minus 1. If you will ask sir why it is minus 1, so let me give you a text. If you are having Gujarati, I think Sangeeta you are having Gujarati book, Chinmay you are having Gujarati book, please go to this section. Okay, chapter, I think the old book it is chapter number 20. Okay, chapter number 20, full other I think other versions I am not sure about. Okay, you can see the basics are discussed over there. Okay, is it there? Have you located? But here in detail I think it is not given compared to the book by Kursanis. I will share the book. Okay, there we can discuss. So let us see the solutions. I think here it will be, it's given one numerical example. When you will do, I think it will be clear. Okay, Madhusmita?
Yes, sir.
Okay, I think Econometrics, that the other book we need actually. Okay, so that book right now I have to locate and then I will give it to you. Okay, PDF form. Okay,
Yes, sir.
but what you should know here is k and m will do numerical, it will be clear, but at least you write it down. Under identified means k less than m, exactly identified means k is equal to m, over identified is k greater than m, and the solution is if it is under identified then it cannot be estimated. If exactly identified means you will use ILS, then if it is over identified you will use 2SLS or instrumental variable. These 3 things you can easily remember. Yes or no, Sangeeta?
Yes, sir.
The other complications are there, but don't think about what we cannot cover right now. When we will have time, we will do that also. But at least you should know when you are going to use ILS and when you are going to use 2SLS or instrumental variable. Okay. So
Yes, sir.
final is order condition for identification is k should be greater than equal to m. So as I told you, it is more technical. So in this case, you will have, if it is like, you can say, when you are going to have a unique solution, we will discuss that. Now let us first discuss why the other options are not actually correct. Over identified equations. So it is like, this option is incorrect because over identified equations have k is greater than m, so we need more instruments than needed. And ILS, if we will apply, it will produce multiple estimates for the same parameter, which will be inconsistent. It cannot uniquely determine the structural parameter from the reduced form. So the solution is, you have to use the two-stage least square approach or the three-stage least square approach if it is over identified equation. So this is something new we are having. Suppose 2SLS provides unique optimal solutions by using all available instruments efficiently. In this case, 2SLS over identified means 2SLS. So now question is, if the demand equation has 3 excluded exogenous variable but only one endogenous variable besides the dependent variable, it is over identified. Then ILS would give 3 different estimates for the price coefficient. How it is, we will do when we will do an example, it will be very clear. Now in option number 3, reduced form of equation. So it is incorrect because it is misleading in the sense that the reduced form of IS, basically it is estimated in ILS but not using OLS or ILS. Okay. So ILS is or indirect least square is the overall procedure name but not the method for the reduced form. And the ultimate goal of ILS is to estimate the structural parameter, not reduced form. So reduced form estimation is just an intermediate step. So what is the important point to remember here is, if there is a reduced form equation, you can estimate directly with OLS, and if there is a structural form, you have to estimate indirectly. This is the simple, you can say, you can remember or you can relate. Then option number 4, why this is again, it is under identified equation, because this option is incorrect, because under identified equations have k is less than m, which is insufficient instrument and it cannot be estimated by any method, and there is not enough information to uniquely determine the structural parameter. So you need either more instrument or impose additional restriction or reformulate the model. Now example is, if both demand and supply equations include P and Q with no excluded exogenous variable, both are under identified, it cannot distinguish demand from supply. Now this is the step, ILS step. First you will have structural equation which you want to estimate. Now because of the simultaneously or endogeneity problem, you have to convert into a reduced form, then you have to derive the structural parameter. Okay, then the result will be the structural estimates which you will be using for your original equation. Now one example we will do. Now we will see what are the things k, m, whatever we have discussed, whether you are getting anything or not. So structural equation, this is the structural equation. This is your demand equation, this is your supply equation, and this is your equilibrium condition. How you will do the identification check? Demand equation, what are excluded variable? There are means no variable is excluded over here. So it included endogenous variable, one is endogenous variable, that is the P. So it means k is equal to 0 over here and m is equal to 1 over here, right? So it means k is less than m. Is it clear how we are calculating k and m, Madhusida, here in this case?
Sir, M means?
M means already I told you, you should remember. What is m? M is number of endogenous variable, na? Included minus 1. K is the number of predetermined variable excluded from the equation. Okay, so what is m over here? You can see m is, you can say, excluded variable. There is no excluded variable in this case. Okay, and the endogenous variable is only one endogenous variable which is having here also and here also. Okay, the same one, you can say one endogenous variable. Okay, So so k will less than m. So in that way it is under identified equation. So similarly, now you just see supply equation. So in supply equation, what is there? So what is excluded? You can say one variable is excluded, isn't it? Now you will be able to relate. So y is excluded, and what is included? One p is already, it is, we know that it is endogenous variable. So k is equal to 1 and m is equal to 1. So k is equal to m means it is exactly identified. Now what is the conclusion? Conclusion is you can estimate the supply equation using ILS, but the demand is under identified. So you cannot use. Okay? Is it clear? So you have to let me give you that book. Then you read more on that, and then I think you will be able to do it. So now supply equation, because it is exactly identified, so now you have to, this is how we derive the reduced form of equation from the structural equation. Basically, so you can say that you have to make it equal, and then you solve for p, then your new equation comes over here, and then you solve for q, then and estimate using the new equation, and this is your new parameter. And from step number 2 is, from after you estimate this, you can go back and relate to the original equation which you have estimated. Now what is important over here is there are different methods are there. So OLS method is there, which is used for single equation, no endogeneity problem, and the result is we can directly estimate. But in indirect least square method, so you need exactly identified structural equation. So in that case you have to estimate in 2 steps. Basically, first is reduced form, and then you have to derive the reduced form equation from the structural equation. Then 2 SLS, 2 stage least square, where the equation is over identified or exactly identified. It uses the instruments efficiently. 3 SLS, it is a system of equation, improved efficiency. So then GMM, general method of movement. So it is also used for over identified equations. Now what is the relationship between exactly or ILS, indirect least square method, and 2 stage least square? So for exactly identified equations, ILS estimate will be equal to 2 SLS estimates. They produce identical results. 2 SLS is more general and work for over identified cases too. So you can say that 2 SLS also you can use when there is exactly identified equations. So what are the advantages of ILS? They give you consistent estimates, then computationally simple, they are intuitive, there is historical importance. Then what are the limitations of ILS? It only works for exactly identified equations. It cannot handle over identified equations, and it doesn't utilize all informations efficiently when k is greater than m, and it is less efficient than 2 SLS, and calculating standard error require additional steps. So why 2 SLS is preferred in practice? It works for both exactly and over identified equation. It is more efficient. Standard errors are readily available from the regression chapter, and rest other points are fine. So now what is the exam strategy? So you have to, the key concept which you have to remember is ILS means it estimates structural equation through reduced form. And then when you see indirect least square, you have to think basically the target is structural equation coefficient, method is indirect via reduced form. Indirect means you are estimating the structural equation through reduced form. So that is why it is called indirect least square method. Condition is when the equation is basically k is equal to m, then only you will be using this. So, and how you can say under identified means k is less than m. So the method is you can say none, we cannot estimate. So exactly identified, you have to use ILS or 2 SLS. Over identified, k k is greater than m, then you have to use 2s and when the ILS fails, basically in this case. Now common question pattern, maybe ILS is used to estimate what, or first step in ILS is what, you have to estimate the reduced form of using OLS. ILS cannot be used for which are the other models, over identified or under identified equations. Difference between ILS and 2SLS method. So why it is called indirect. So these are the important concepts which you should know. And structural equation is true economic relationship. Reduced form is endogenous as a function of exogenous only. Simultaneous bias is OLS bias from simultaneous determination. Identification is whether the parameter can be uniquely determined or not. Now let's say that some questions we can see what is the first step in ILS estimation procedure. First step is you have to estimate the reduced form equation using the OLS. For which type of equation does the ILS provide unique estimate? If the equations are exactly identified, there it provides unique estimate. And question number 3 is an equation has 2 excluded exogenous variable and 3 included endogenous variable. Is it identified? So obviously unidentified is k is equal to 2 and m is equal to 3 minus 1, it is 2. So because it is k is equal to m, so it is exactly identified. So then you can say the question number 4 is why cannot ILS handle over identified equations? So over identified equation produce multiple different estimates for the same parameter when using ILS, leading to inconsistencies. 2SLS resolve this by combining the information optimally. So now this question is this section is like little tricky. So what you have to remember is at least where you will use ILS, where you use 2SLS, where you will use 3SLS, and then the identified you can say conditions, because they will ask you like they will not give you equations, maybe they can give let me think how we can simplify further, but at least these three conditions you can remember, and the different methods of estimating along with OLS, what are the other methods, at least you can remember this, and it will give you at least you will be able to answer some questions from this section, right Sangeeta? Little tough,
Yes, sir.
little tough, but what you have to remember, it is clearly given, okay? At
Yes,
least you
sir.
can remember till we will do this in detail, okay? So we'll go to the next question, okay? Next question is question number, let's say that probability question Q4 question. If we'll go question number 4, this is a question. I think this one you can easily do, right? If x bar is equal to 32, y bar is equal to 38, regression coefficient is bxy is equal to minus 0.2337, byx is this. Find the equation of the line regression of y on x. Which is the answer, Sangeeta? This question? Question number 4. Any idea? How you will solve it? You'll be able to solve
It
it?
will be either, sir, it will be either 3 or 4.
Okay. Chinmay? Okay.
Sir,
Yes. You'll be able to solve it? Yes, sir?
I will try, sir.
Okay. Madhusudhan, you will be able to solve it, right?
Sir, actually.
Now, this is the easiest direct question, actually, compared to the previous one which we had discussed. So, basically, let's see. Option number 4. I think uh, Sangeeta is correct. Now, let's see. Ajay, option number 4 is correct?
Yes, sir.
Okay. Very good. So, mute yourself. So now let us understand, okay, why, how you will be solving it. First of all, in a vibrant data, there are two regression lines. I think already I had given you these equations. Suppose if when you are running regression of y on, or when you are estimating y on x, means y is your dependent variable and x is your independent variable, then the regression equation we write like this: y minus y bar vyx into x minus x bar. Always you just see y, because there is no confusion over here. Whenever you are starting from the left to right, left y means it will be y minus y bar. Then the other side you can easily remember. And the coefficient byx is regression coefficient of y on x. So when you will use, when x is independent variable and y is dependent variable, and then second is regression of x on y. So your dependent variable is x, independent variable is y. So the regression equation is x minus x bar, that is which is equal to vxy into y minus y bar. So the coefficient is vxy is equal to regression coefficient of x on y. You will use when y is independent variable and x is dependent variable, right? So now what is important clarification? Byx is regression coefficient of y on x. The slope when you are predicting the y. Pxy is regression coefficient of x on y. So now you will be able to solve it after these equations are given to you. So this is already there. So now we will solve step by step. So what you are given, x bar is given to you, y bar is given to you, this is also given to you, right? Sangeeta? Bxy is given to you, right?
Yes, sir.
Byx is also given to you.
Yes.
So step number 1, what you have to find? You have to identify the correct coefficient. Suppose you want regression of y on x, then you will be using byx,
Yes, sir.
not bxy. But if you if you are in a hurry and you will use bxy, then it will be incorrect.
Yes, sir.
Then step number 2, general form of the regression line of y on x is y minus y bar, which is equal to byx into x minus x bar. Just you have to substitute the value over here.
Sir.
So y minus 38, just you replace this value, then you will get this equation. Is there any doubt, Madhusita?
No, sir. Just the calculations we have to do.
Madhusita, are you
No,
having? Okay.
Yes. No, sir. Doubt.
This is straightforward, no? So that I don't think it will be any problem. Similarly, you will be doing like rest. What you will be doing is, because how you can verify. This is also very important. How you can verify, because already you have estimated this. So already you know that your regression line passes through the mean value of x bar and y bar, right? X bar and y bar. So 32, 38. So already if you will put the x bar over here, then you will see that you will get y bar value. Are you getting?
Yes, sir.
This is how I think this is an important step. How you will verify. Are you getting my point?
Yes.
If your regression is this, if you remember, I told you the numerical properties, right, of regression. So just you replace with the regression equation the x bar value. Then if you are getting the y mean value over here, then you are actually correct. Okay. Now these are the different formulas. I think already you have written all these formula. So I will pass you the notes, right? So there is some other formulas. I think already you know it, isn't it, Sangeeta? This formula.
Yes, sir.
So there is no other corrections. Of course, the other options will be not correct. So you can. What is important? This is very important. When you are addressing this kind of question, first you check whether it is x bar or y bar. If you are not getting y bar value, straight away put the x bar value and see whether you are getting y bar value or not. Are you getting? This is a better method to check. Madhusita, you are aware about this point, how you can verify
No,
earlier?
sir.
So this is, you can say this is very important. Chinmay, is it
Yes,
clear? Means, are you aware that how you will check whether this equation is actually the original equation which you are looking for the answer or not? Just you have to replace the x bar over here, and if it is equal to mean of y bar, then it is fine. If other equations, other options, wherever it is not coming equal to 38, then you have to simply say incorrect. You just see, our correct option is having this. Are you getting?
Sir, how can we identify it is a byx or bxy? Sir, there is some problems.
Madhusida, you tell. Madhusida.
Sir, actually, in this section, I have also doubts.
No, no, no. Okay, let me see. Sangeeta.
Yes, sir.
So bxy, what is given? Let's see. So you just see. Bxy is directly given, na, Ajay?
Byx and bxy both values are given. So we
Yeah.
have to see that the line of regression is y on x or x on y. So if it is y on x, then x is the independent variable. So in the left hand side, y minus y bar will be there, and in the right hand side, x minus x bar will be there. And we will use byx.
Now let's see. Yes. Suppose byx, you are saying.
Yes.
Suppose here in the fourth option. Okay. Now the question is fourth option. Please remember this choice. Okay. So what is actually happening over there? So y is equal to, suppose now this coefficient, suppose you can say this equation is there, right? So what is the x bar value? Directly you have to see, na? Right? Suppose you just see fourth option is byx. But Ajay, I don't think any problem will be there. Just you multiply here, na? The value of x bar. Is it coming? Can you check? Have you checked? Have you checked? Just you check. Sangeeta, check. In the first option, check how much. Quickly, can you tell me? Y bar is how much? Let us use the calculator. Madhusita, do it. Then only your doubt will be clear. No, no, just let me say first what you want to do. Let me tell you. Minus 0.2337, okay, minus 0.2337 into how much? Into 32, right? Is how much? Minus 7.4784 plus 40.8806. Is it clear? So how much we are getting? 33.4022. 33.4022. Is it fine? In this way you will go, na? Sangeeta?
Yes, sir.
Then I don't see any doubt over there, isn't it?
Yes, sir.
Chinmay, are you clear?
Yes, sir.
Means you will be able to check if this
Yes,
kind
sir.
of question will be there. How you will check?
Sir,
Means you will put x bar value into the equation, right? And see,
yes.
you will check whether you are getting y bar or not,
The
right?
Y boundary.
Right? Is it clear?
Yes, sir.
Okay. Yes, Madhusita, now you can ask. What is your doubt?
Sir, actually, in this section, I need a more practice, sir. do not understand anything.
No, what you need to understand here? You have to understand the equation only. So just you have to see the equation y minus y bar is equal to into byx into x minus x bar. So already this is your equation, right? Which is already there. So now just you have to replace just to verify it. And if you need more practice, so it is given in detail. Okay, please do it.
Yes, sir. Yes.
But what you should remember is like at intersection point, what are the important properties? Both line intersect at x bar y bar. So it is like this. Your regression line is like this. It will be like this is your x bar and this is your y bar. But why we are cross checking? You know that because of this line means when you are putting this value means we are replacing x bar into the equation. So if we are getting means, so then definitely at this point your regression line is passing through x bar and y bar, na? Are you getting, Sangeeta?
Yes, sir.
Okay. So you read more on this, okay?
Yes,
So
sir.
now, what is the exam strategy? Exam strategy is, as Ajay asked, regression of y on x means you will use byx. Ajay, is it clear? Regression of x and y means you use bxy. Okay? And when we use this word, line of regression of y on x means you will use byx. So the how you can memorize this, the variable after or of and before on is the dependent variable. Okay? And how you can identify the correct coefficient, regression of y on x, byx, regression of x on y, bxy. Common mistake is this, bxy, when you are asked to estimate use the regression of y on x, you have used the bxy. So this is the formula you have to remember, and if you will expand this, what this formula is having. So basically it is having the intercept, the way we used to derive in the OLS estimator. So that is what it is given. So rest of the thing is fine. So now let us do one more question. For the same data, find the equation of regression of x and y. Chinmay,
Yes, sir.
how you will do? X minus x bar. What is the equation? X
Sir,
minus x bar
x minus x bar
is equal
equal
to,
to
yes,
b
b
bxy
bxy into y
into
minus.
y minus y bar.
Okay, very good. So you simple what you have to do is x bar is given to you, y bar is also given to you, bxy is given to you, byx is given to you. Simply you replace the value y minus y bar value. So it will be x will be equal to directly if you will expand it, so it will be minus 0.2337 y plus 40.8806. Isn't it, Sangeeta? You will be able to solve it? Question number 1. Madhusida?
Yes, sir. Now I understand it.
Okay, very good. Thanks. So, now what is the correlation coefficient between x and y? How you will find out? Chinmay? How you will find the correlation coefficient?
Sir, r equal to minus bxy into byx.
Not minus. Square root, na? You can
Yes, sir.
byx, yeah, it is given over here. What is the correlation coefficient? byx into bxy. You will take the square root. So,
Sir, in correlation coefficient, we do not have r square. We only have r.
that is fine. But r square, usually the formula is here. Means if you remember, I have already given this formula. What is the formula here? If you see, we'll go detail over here. Can you see? Bxy into byx is equal to r square.
Yes,
Are you
sir.
getting?
Then
Yes.
sir, R,
Then
when
r
we
is
calculate
thus,
R, then
yeah. If
what
you
will
will if
be?
you will calculate r, it will be plus or
Plus
minus.
minus, plus minus.
But this is a catch also. So when you will r, suppose now the question is, you will say, sir, r square is positive number, but when you will take the square root, it will be plus or minus. Now how will identify which one is your correlation coefficient? Because both the regression coefficients are negative and r is less than 0, so then only you will say r is less than 0. Are you getting? Now if you will assume that it is 0.3939, then there is a problem. Are you getting my point? Because r is plus or minus bxy into byx. Is it clear? Means you have to be very careful, otherwise you will lose the mark, even though it is easier. Sangeeta,
Yes, sir.
Okay, sir.
which one you have to look at? The coefficient sign. Okay. If the coefficient signs are negative, then correlation is also negative. So similarly, if the coefficients are positive, then correlation will be also positive. Then you will be taking positive number. Is it clear, Chidbhai?
Yes, sir.
Okay. So that is like sometimes question will be here and there, but you have to remember the tricks, and so that is what it is saying, x and y. So that is why it is negative, we are saying here in this case. Sign is negative because both the regression coefficient are negative. It is clearly written. And if you substitute x is equal to 32 in the regression of equation y and x, what will be the value? So of course the value will be 38, because just you are multiplying over here. Then why are there two regression lines? So because correlation is not perfect, r is not plus or minus 1. So one line minimizes the vertical distance and other line minimizes the horizontal distance. So when there will be only one regression line, this is also very important question. If the correlation coefficient is equal to 1, then you cannot have y on x and x on y. Are you getting? Understand that?
Yes, sir.
If your correlation coefficient is 1, means what? There is a perfect.
Perfectly correlation.
Then what is the importance over here? Means how we will relate, because we are discussing in depth. Then you cannot have y on x and x on y. Two regression line. You will be having only one regression line. Okay?
Yes.
Either y on x or x on y.
Yes, sir. Right.
Yeah. So that is the end of this question. So we will go to the next question. This is question number 4 we have discussed, right? Then we will go to the next question. This one is easier. I don't know, this is coming from sampling methods and sampling distribution section. This question was little tough. Just you see, read this question. The management of a manufacturing firm wished to determine the average time required to complete certain manual operation, and there should be a 0.95 confidence that error in the estimate will not exceed 2 minutes. Then what sample size is estimated by time and motion study expert as 16 minutes? First of all, this question if you read, then you will get afraid, right? That I will not able to do it.
Completely.
But if you will be patient, and what usually the strategy is, if some questions are bouncing at the first instance, so you just skip it and go for the easier ones. Okay, then you come back. Now what is it saying? Let us see how we can solve this. Okay, because this is a difficult number, so let's say the option 4 is the answer. Okay, now what we are having actually, this is the answer. Now we will see how we are getting the answer in this case. So all of you are having the questions, right? When I am solving, you are having the questions with you. You see the questions. So because otherwise you will forget now what is happening over here. So first of all, in this question, we are given to find the sample size which is required to estimate the average time, right? With these conditions. Confidence level is given over here. So what is given? Margin of error is given 2 minutes. Population standard deviation is given. That is estimated by the expert. Are you getting my point? From the question you have to identify this. Are you having the question? You take a screenshot when we are solving. If you are not having the questions. I think Sangeeta, you are having the question, you take the screenshot, okay?
Yes, sir.
Chinmay, you are having the questions?
No, sir.
June 2025 question you have downloaded, na? So you parallelly you can have it on your mobile or you take a screenshot. Have you taken the screenshot?
Yes, sir.
Okay, very good. Madhusudha, you are having question?
Yes, sir.
Okay. Now, what is given is clear over here? Confidence level is already given. Margin
How
of error. Huh?
standard deviation is 16 minutes.
Sorry?
Sir, how we know that standard deviation is 16 minutes? Because here
Not standard deviation. It is population standard deviation.
the population deviation.
Sigma. Because it is estimated by the expert. Na? It is saying. You see? What sample size is estimated by time motion study expert as 16 minutes? Because what it is saying, the management of a manufacturing firm wishes to determine the average time required to complete certain manual operation. This sentence is clear, right? So they need an average time for completing certain tasks. That is the question. But now that average time, how they will calculate? They want to calculate with 0.95 confidence, means basically 95% confidence level. And the margin of error, it should not actually exceed 2 minutes. And then what sample size is estimated by a time and motion study expert as 16 minutes. Because it is given by the expert, right? So because it is not coming from the sample, na? Are you getting my point? It is given. It is given. Now your question is how you will know that whether it is standard deviation or any other number.
Or yes, sir.
But other values are clear, right?
Other values are clear.
But you just tell me one formula we had discussed in the class. I think you might have not there in the statistics class. How you calculate standard error? Standard error
Yes.
is basically
Standard deviation divided by root n.
root 10 we calculate, right?
Yes.
Now our focus is on n only, right? Sample size. Are you getting my point?
Yes, sir.
So when we are talking about sample size, so what we are given basically the expert, because company wants to find the average time required to complete the certain manual operation. Now expert has come and told that let's say 16 minutes is the average time which is required to complete this task. So from this formula we can relate. Yes, it is not directly given. Now from your, when you will do more and more problem and you will think clearly, then it will be clear. Okay?
Sir.
From that formula only. Okay, let us see. So now we will find the minimum. Our goal is to find the minimum sample size n needed. The sample size formula for estimating the mean. When estimating a population mean with a specific confidence level and the margin of error, we will be using Z over here. So sample size formula is n is equal to Z alpha by 2 into sigma upon E. Okay? Into, means basically it is a square. Z alpha by 2 into sigma upon E square. So n is your required sample size. Z alpha by 2 is the critical value. Sigma is the population standard deviation. And E is the margin of error. Now you can go whatever it is given to you. So first is you have to identify the Z value. But Z value is not be given in the exam. But as I told you, certain Z values you have to remember. Okay, one or two values you can easily remember, not a problem. So 1.96, if I remember, I told you, Sangeeta, earlier, for 95% level of confidence or 0.05. Have you remember this, Sangeeta?
Sir.
Huh? Yes or no?
Yes, sir.
Okay, then you know Z value. Z critical value, you remember. T critical value, at least 5% you can remember, because they have not given, but they are asking the question. Are you getting my point? They know that, they are assuming that you know it. Now Z alpha by 2 value is 1.96, sigma is 16 minutes, E is 2 minutes, error. Now you can easily find out. Na? Are you getting my point? Ajay, the answer is correct or not? 246. Option was there? Yeah, there. Option 4.
Yes,
What is,
sir.
it is there? It is correct? You have not checked, right?
145, 245 point something.
That is fine. Yeah, that is right. So now Sangeeta and others. So what you can remember is this sample size formula you have to remember. This is the takeaway. This is important. And it is not that difficult to remember, I think. Z alpha by 2 you have to remember into sigma upon error square.
Sir, the problem is there. Problem means doubt is there ki how to calculate the Z value here. Means 95 confidence level is there, so 1.96.
Yes.
If 99% confidence level,
You have to remember also, na? 5%, usually 5% is given actually. Means usually most of the, as I told you earlier also, most of the problems, unless until it is given 99% specifically, if you are calculating 95, it will be accurate. Means you will get the answer. If they will require specifically in the question, they have to give. That is why these questions are tricky, I told you. Otherwise, anyone can confuse, because it can be 90% also. Are you getting my point? So, now what is the confidence interval? Confidence interval. So, what are the important concept which is related to here? A confidence interval provides a range of values which likely to contain the population parameter. So, for a population mean, confidence interval is x bar plus or minus z alpha by 2 into sigma upon root n. So, x bar is sample mean, and how you calculate the margin of error? Through this formula, z alpha by 2 into sigma upon root n. That is the standard error. Now margin of error requires the maximum distance between the sample estimate and the two population parameter. Basically, margin of error means this. So you calculate like this formula. So you please write down this formula, because these are very important. And this is how you get n. Okay, how we got from, if you are thinking how we got from margin of error to here. Then what is important over here? 95% confidence means what? If you take 100 different samples of size n, 246, then you will calculate the sample mean for each. Then you will construct a confidence interval for each one of them. then approximately 95 out of 100 intervals will contain the true population mean. So it means what is important over here, it doesn't mean that there is a 95% probability that the true mean is in any specific interval. What it is there? It is 95 out of 100 intervals will contain the true population mean. Now, as you all have agreed, means you have asked what are the common Z values, right, Sangeeta? So 90% Z values is 1.645, 95 1.96, 98 2.33, 99 2.57. What you have to remember is 1.64, 1.96 and 99 is 2.57. So what is the memory, means how you can memorize it? So if we will put approximate value also, it's fine, not a problem. We will get approximate answer, not a problem. So what are the factors affecting the sample size? Higher confidence means, this is a very trick. Higher confidence means larger sample size needed. As Ajay was asking, if you need Ajay, just see this. Is the other options are available? 4 to 4 option is there, Ajay, in the question?
Yes,
Sangeeta,
sir.
is there? 424 is here or not?
Yes, sir.
Where it is? In the question it is there?
Option 4.
246.
Oh, 246.
No, sir. 255 is there.
100 is there, no?
Huh? Which one? Which one? Which one, Sangeeta?
Sir, I mean that more than 240 values are there.
173 and 246. Both are there.
Both are there.
No, sir.
Where? 173 now is not there.
No, sir.
Sangeeta? Huh?
Like you said, no, the more the confidence interval, higher the
No,
value
no,
will be.
that is fine. But Ajay asked a question na, that how we will know whether it is there any 99% value is here or not. So we are cross checking na.
Okay.
Are you getting my point? So in these options, Chinmay, you got it?
Yes, sir.
So other options are not there. Means basically you can see the sample size. Sample size with 90%, it will be 173. This option is not there. This option is also not there. Only 246 option is there. But Sangeeta, you are fine. So like the confidence, like suppose more confidence means you require more data. Now let's say that if I don't know all this formula, like if I would have been in your place, right? Like I am making a perfect guess. Means if you guess just randomly, you can think a bigger number. Then it is incorrect. You think how big it is. Because you will think na 0.95 confidence. But I think just you put the quickly 1.96 value, you put into the margin of sample size formula. But I think it is not that difficult, isn't it, Sangeeta? If we able to read the question properly, right?
Yes.
This
Only
formula is not difficult.
no.
This formula. Are you getting one?
Value, sir.
Uh-huh.
We have to remember the critical value
And sigma value.
and we have to know that this is the sigma. Like here, sigma is 16. So we have to judge that
You
activity.
because there is no other value also. Another trick is why you will be calling that sigma is there is no other value also in this question. Na? You just see you are only given 3 numbers, right? This is given to you. This is given to you, margin of error. Now what is the third thing you need in this formula? You just see what you need, Sangeeta. This is given, right?
Yes, sir.
So this you have to calculate. Then you have to think, this is, means let's say that you asked how we will do. So you don't have any other choice now also. Are you getting my point?
Yes, sir.
So your strategy, elimination, right? Or here there is no other option left over here.
Yes, sir.
So now it is like n is equal to 246. So this is how you will understand. So this I will give it to you. You read. Okay. I think I have not shared all these documents with you, right? This yesterday's discussion and today's discussion I'll share.
Yes, sir.
Okay. So now what is the effect of margin of error? Smaller error means you need large sample. With 95% confidence and sigma is 16. Suppose let's see the margin of error. What is the margin of error? The question is asking, Samita. 2 minutes. Right?
Yes, sir.
But if the margin of error will increase 4 minutes, you just see, you need smaller sample. Right? So when the margin of error is increasing, smaller error means more sample. You have to remember. Okay? Larger error means small sample size. Is it correct? Basically, inverse
Yes,
square
sir.
relationship. E doubles, n becomes 1 by 4. Suppose let's discuss like this. So if you are a researcher, let's say that you know that plus or minus your error will fluctuate within 2%, whatever you are calculating. So what you should target? Means you will target this. Then if you will take less sample size, then your error will be high. You know it. Are you getting my point? So as a researcher, suppose if this kind of question will come. So how we will choose the sample size? Sample size is always depend on how much error you are targeting. Are you getting? Sangeeta, is it clear? Then effect of standard deviation. Higher variability means larger sample size needed. With 95% confidence, E is equal to 2. So now 8 minutes means 62. If the standard deviation will be 20 minutes, you need here because it is 16 minutes, this is 246. Now if it will be much higher, then you need more. So inside is more variable population, need larger sample for the same precision. So why the other options are incorrect? So already we know that you have to remember like this. You can check, okay, you can cross check. Are you getting my point? 96. First value was 96, Sangeeta, isn't it? So just you put this value over here and see the margin of error is exceeding 2 minutes. Is it clear now? Madhusita?
Yes, sir.
Now option number 2, you can see it is 1.81 minutes. So now option number 3, 245, it is 1.96. Very close answer they have asked. Are you getting my point? So that
This
is
method is more easier than the faster, sir. First one.
but I'm just telling na. They are asking very close options. You just see 1.81 error, 1.96. So that is why there will be possible confusion in you are going to have this case. Because Z is equal to, suppose let's say that you will round up. Okay, rounding up Z 1.96 to 2. If you are irrespective, like if you will take Z 0.025 or alpha 0.05 value, that 1.96, rather you will take 2. Those who will consider, because they will not remember, they will say okay, it will close to 2. Then in that case you are going to have 255 means 256 basically. So that is very problematic. So that is why you have to use exact Z values for accurate calculation. So now you just see Ajay, you look confident with this formula, right? You can cross check, right?
Yes, sir.
Now next question, Sangeeta, your answer will be here also. How you will, when the standard deviation is unknown, let's say that if there is a standard deviation is not known, how you will do? This is a practical question. I think we will not discuss pilot study, previous study, rule of thumb, right? So this is
Yes, sir.
not required. I think you will skip it. It is for Madhusmita. You read it, okay?
Yes, sir.
You should do the detailed study.
Yes,
Not
sir.
now, after the exam.
Okay, sir.
Okay. So now, what is the exam strategy? This is very important. You have to, like, when we read at the first time, it will not be very clear, or we should not get afraid. What sample size is needed? Clearly, you will write n. How many observations should be taken, or minimum sample size required? Determine the sample size. Similar kind of phrase will be there. And you have to look for the component confidence level. So either it will be like this. Margin of error not exceeded within standard deviation. Standard deviation is expert estimate. So Sangeeta, your answer. Expert estimate means that is the maximum value. Okay. Ajay, please mute yourself. Huh? Ajay, mute yourself.
Sir, I am mute already. Like Madhu madam is unmute, I think.
Yeah, please, Madhu, mute yourself.
Yes, sir.
So for population mean, are you getting? Then you use this formula, means basically for population proportion we can use, if there is a percentage form, if it is given, then in that case we will be using in this way. Okay. So key value you can memorize 1.96, 1.645, 2.56. So we can give this number like this. So 90% is Ajay. So your value is 1.645. Ajay, you remember your number. And Sangeeta, your value is 1.96. Okay.
Yes, sir.
Chinmay, your value is 2.576. So you can remember what is your number.
Yes, sir.
Okay, very good. So now one more question we will do. What would the required sample size be if we wanted 99% confidence instead of 95% with error 2 and sigma 16? Sangeeta, are you able to solve this? What it is saying? Question first, focus. What would be the required
Yes,
sample
sir.
size if we wanted 99% confidence instead of 95%? Ajay, your question.
Yes, sir. It will be. I can do that.
4 to 5. You can do it, right?
Sir.
Question number 2. If we can only afford a sample of 100, what margin of error should we expect? We expect 3.14 minutes. Okay. Question number 3. What happens to the required sample size if the margin of error is half, from 2 minutes to 1 minute? Sample size become 4 times larger. Simple. And because the n is inversely proportional to square. Why do we always round up sample size? Rounding down would give us the slightly less than the desired confidence level and precision, but we need at least the calculated sample size to meet our requirement. Okay? Shall we proceed to the next question, or we will do it tomorrow? Question number 6 and 7. Question number 6 is the difficult one, so it will take little time. Poisson distribution. Sangeeta? Question number 6 is this.
Tomorrow, sir.
Okay. Or then we'll do question number 7. Okay. Not a problem. But what we'll do is, let me see, 1 second. I'm not getting where is Zoom. Okay, let me see. You are able to see the screen?
Yes, sir.
Okay. But okay, I have kept it here. So now what I'll do is I'll stop recording.